In this problem, we are using a linear function or the linearization of a function to approximate the value somewhere on that function that's nearby. So the basic idea behind this is you might have a function. In this case, we've got the square root of x, which looks something like that. And if you can figure out an equation for the line tangent to that at some place, then in that general area, that line, that linear function, is going to be a good approximation. So, and usually it's pretty easy to compute the value when you have that linear function. Easier than it is to say compute the value of the square root of 24 without a calculator, which is what we've got going on in this problem. So our function is the square root of x, and we want to find the linearization of that function at a value of 25. So what that means is we want the equation for the tangent line to the function at 25. To get the slope, we're just going to take the derivative of our function and then plug in 25. And to get a point, we're going to plug in 25 into the function. And once we've got a point and a slope, we'll have a linearization or a linear equation. Okay, so let's do that first. I'm going to write this as f of x equals x to the 1/2 when we take the derivative, so f prime of x. That's going to give us 1/2 times x to the negative 1/2, which you can write as 1 over 2 times the square root of x. So that's our equation for the derivative. Now the slope at 25 is going to be this evaluated at 25. So if I put a 25 in there, that's square root of 25 is 5 times 2. So that's 1/10. So the slope of our line is 1/10. And that fits when you get pretty far out on the curve of square root of x. It's pretty flat, and 1/10 is a very shallow slope. Now let's get our point by plugging in our x value of 25 in here, and that's pretty easy. We just take the square root. So the point 25 comma 5 is on this curve, and in fact, it is that point where the line touches the curve there. So the line also shares that point. So now we can use the point slope form to figure this out. So we've got y minus 5 equals 1/10 times x minus 25. And we could add 5 to both sides. I'm going to multiply through the 1/10 here first. So 1/10 x and minus 25 tenths. I'll just leave it like that for right now. And then I'm going to write minus 5 as minus 50 tenths. And then we're going to add 50 tenths. So what you can see is this will be y equals 1/10 x plus 25 tenths. And 25 tenths is 5/2. You divide those both by 5. So we've got 1/10 x plus 5/2. This is the linearization. So they use the terminology big L of x instead of y there. So that's what we're looking for when we find the linearization. So 1/10 x plus 5/2. And now it says use that linearization to approximate the value of the square root of 24. That's an appropriate tool to approximate the value of the square root of 24 because the square root of 24 is going to be pretty close to the square root of 25. So this line, which is not the square root function, but it's a line that's going to have values very close to that. So we should get a good approximation of this. So what we're going to do is just plug in 24 for x in our linearization. So we're going to get 24 tenths plus 5/2. And let's see, 24 tenths, that's going to be 12 fifths plus 5/2. That is going to be 4.9, right? Yeah, I think that's going to be 4.9 because this is 2.4 and 2.5. Yeah, so that's 4.9. I'm just going to take out my calculator and plug in 24 square root here. Give me a second to do that. So 24 square root, and the value is 4.8989. So very, very close. So you can see that a linearization works pretty well to get you darn close to the value you're looking for. So that's a little more work with linearization.